Hello and welcome to 8th grade. Today we're going to start on Module 1, Lesson 1, the topic of exponential notation. Now what I'm going to start on is a quick review of what exponential notation means. If we look at the phrase exponential notation and take a look at each word, we can see an exponential. There's a root word of exponent, which means there's going to be an exponent involved. If you remember from 5th grade, we started first seeing an exponent whenever we saw things such as 10 to the third power. And the 3 would be your exponent. And notation basically means a different form of representing numbers or an operation, different ways of looking at that. One example is whenever you were first learning multiplication. You had something called repeated addition, which is, for example, 5 plus 5 plus 5 plus 5. That's adding numbers together repeatedly. And later on, we learned that that was just multiplication. So a different notation of writing 5 plus 5 plus 5 plus 5 is the same thing as saying I have 4 copies of 5. So 5 times a total of 4 copies of 5. So 5 times 4 is 20, or 5 plus 5 plus 5 plus 5 is 20. They give you the same answer, but they write them in a different notation when you go from repeated addition to multiplication. The same thing happens whenever you go into exponential notation. Instead of going from an expanded form such as this, you bring it down into an abbreviated form. So if I were to have a repeated multiplication of 5 times 5 times 5 times 5, I know that 5 times 5 is 25, times 5 is 125, times 5 is 500, 600. But there has to be an easier way for me to write this whenever I'm writing my answer. And what we've learned in 7th grade is that you can put that in exponential notation. You have a base of 5, which is right here. That's my number that's being multiplied over and over again. And it's being multiplied a certain amount of times. And that number is 4. It's being multiplied 4 times. So my exponent would be 4. If I were to go from an exponential notation back to expanded form, like let's take my 10 to the third power like I just did. 10 to the third power. If I wanted to put that in exponential form, I know that my number that's being multiplied over and over is this base number of 10. So I have 10, and that appears to be multiplied 3 times. So 10 times 10 times 10. A total of 3 10s being multiplied. And I know that 10 times 10 is 100. 100 times 10 is 1,000. All of these 3 different notations equal the same number of 1,000. But this exponential notation is how you take a repeated multiplication problem into an exponential form. Now I'm going to stop this video and start one on how we can work our lesson. Alright guys, so we're going to start with our exercises on Module 1, Lesson 1. And what that first set of exercises basically are is if it gives you a set of repeated multiplication, they want you to write it as an exponent. Or if it gives you an exponent, they want you to tell me how many times that number was multiplied. So let's look at exercise 1. 4 times ... times 4. Remember what that ... means is like basically saying over and over and over again until it ends, meaning it's always doing multiplied by 4. And then it says being multiplied 7 times. So 4 is being multiplied repeatedly 7 times. So that means my base is 4, and the exponent, being that it's multiplied 7 times, it will be 7. Exercise 2, 3 6/10 times 3 6/10, 3 6/10 for a total amount, and the product, or the exponential notation, is 3 6/10 to the 47th power. So looking at that, I can ask myself, well, how many times is it multiplied? Well, if its exponent was 47, then it was multiplied 47 times. Let's go up here to exercise 6. I'm going to work a few of these, and then I want you guys to finish the rest. Exercise 6 says 7 halves, so 7 over 2, times 7 halves over and over and over again for a total of 21 times. Now, what this means is 7 halves is being multiplied 21 times until it ends. So my base is going to be 7 halves, and my exponent is going to be 21. Now something is missing right here. Whenever you have a fraction that you're making go up to an exponent, an exponential power, you need to put that fraction in parentheses because it is 7/2 that's being multiplied over and over again repeatedly for a total of 21 times. If I were to leave it as 7/2 and put this 21 up here, it looks to me like this is 7 to the 21st power divided by 2. So you want to make sure that you leave those parentheses and put the exponent on the outside of the parentheses if it's a fraction that's being multiplied repeatedly. All right, so then let's look at exercise 7. -13 repeated a total of 6 times. So my base is -13. And my exponent is 6. Let's take it down to exercise 9 because we have a variable here. Remember, a variable is a letter that represents a certain number that we don't know. It's unknown. So I have x times x times x times x times x, a total amount of times until it stops, and that total time is, it looks like 185 times. So that means my base, even though I don't know the number that it is, it's still x. My base for my exponent notation is x with an exponent of 185. So it's x to the 185th power. And let's look down here. X times x times x a certain amount of times, and then I end up with x to the n power. X to the n power. Now I have two variables here. I don't know the number that x is, but it's still a number, I just don't know what it is. And I have a variable as the exponent as well. That number can be anything. I don't know what it is. So whenever it's asking me how many times it was multiplied, I don't know, but I do know that n represents that number. So that means x is being multiplied n times. Okay, so I've worked exercise 1, 6, 2, 7, 9, and 10. You guys finish up exercise 3, 4, 5, and 8, and then we'll move on to the next set. Okay, let's finish up our exercises by moving on to exercise 11. It asks, will the products be positive or negative? Now remember, an exponential notation is repeated multiplication, so the answer, whenever you solve it, is still going to be a product. So that's what it means by what product, will the product be positive or negative? Will the answer when you solve this be positive or negative? Well, let's look at it. I have -1 to the 12th power. And what that means is I have -1 times -1, a total of 12 times. So that means I multiply this out. Now I'm not going to do any math here. I'm going to give you a shorter example. 12 is a positive exponent. So let's do it with a smaller positive exponent. Let's look at -1 to the 2nd power. And not a positive exponent, I'm sorry, an even exponent. 12 is an even number, 2 is an even number. So -1 to the even number of 2, the 2nd power, is the same thing as saying -1 times -1. And if I have 1 times 1, we know that that equals 1. But right here I have a negative times a negative. Remember in 7th grade we went over those rules? Whenever you have a negative times a negative, it equals what? It will always equal a positive. So whenever you have an even amount of negative numbers being multiplied by each other, your product is going to be -1. And if you don't believe me, we can do -1 to the 12th power. That is -1 times -1 times -1 times -1, blah, 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 until we get to 12. But look at this. -1 times -1 is going to be a positive 1, like we just said. And then you multiply it again by a -1, making it negative. Then you multiply it again by a -1, making it a positive. And it goes on and on until you get to the 12th one. But because you're multiplying by an even amount of numbers, that negative will always end up being a positive number. Being that 12 is even, -1, whenever it is multiplied by itself 12 times, it will end up being a positive 1. That's the same thing that happens down here. When you have -1 times -1, a total of 13 times, then I have negative 1 to the 13th power. Now let's break that down to a smaller number as well. Let's do 13 is an odd number, so let's do negative 1 to a smaller odd number of 3 to the third power. That looks the same as negative 1 times negative 1 times negative 1. So let's multiply that. Negative 1 times negative 1 is going to equal what? A negative times a negative is a positive, so we have positive 1. And then I still have to multiply it by this negative 1 over here. So I have 1 times negative 1, and we know that 1 times 1 is 1, but whenever you multiply, remember, by a positive number and a negative number, the answer will be negative. So what that says is, anytime I have a negative exponent, not a negative, I get those mixed up. Whenever you have an odd exponent, your answer, if this is negative, if you have a negative number inside the parentheses and the exponent is odd, your product will always be a negative number. But if you have up here a negative number inside the parentheses and your exponent is even, your answer will always be an even number. It doesn't matter what number's in here, as long as it's negative and your exponent is even, it will be an even number. A positive number. If your exponent is odd and the number in here is a negative number, your answer will always be a negative number. So, that being said, exercise 12 says, is it necessary to do all of the calculations to determine what sign of the product, what sign of the product will be? Why or why not? Well, if you look at it, I have a negative 5, which means I have a negative number that's being repeated over and over, to the 95th power. So you see that you have a negative number in the parentheses, and it's to an odd exponent. And it says, is it possible to determine if the sign of the product is going to be odd or even? Negative or positive. And the answer is yes. No, we don't have to do any math because I have a negative number in the parentheses. It's an odd number, so I know for sure that this is going to be a negative number, because if you take a negative number to an odd power, it will always be negative. If you take a negative number to an even power, it would be positive. But being that I have an odd number as my exponent, this is going to be a negative number. I don't know the answer because I didn't do the math, but I can tell you what the sign is going to be. So if I have negative 1 8/10 repeated 122 times, so I have negative 1 8/10 to the 122nd power, I have a negative number in the parentheses to a even number. So can you tell me what the sign would be? I know that if I have a negative number to an even power, that my sign is definitely going to be positive. I don't know the answer because I didn't do it, but I do know for sure that it is going to be a positive number. All right, guys, we're going to finish up with our last few exercises. Fill in the blanks indicating whether the number is positive or negative. If n is a positive even number, then negative 5 to the n power, so I have negative 55 to the n power. I don't know what that number is, but over here it says it's a positive even number. So that means I have a positive number that's even, and that means I have a negative number to an even power. So what is the sign going to be? It's going to be a positive number because it's even. It's an even number in the exponent. Then if I have negative 72 4/10 to the n power, where n is a positive odd number, then that means I have a negative number to an odd power, which means it will be negative. And lastly, Josie says that negative 15 times itself 6 times is negative 15 to the 6th power. Is she correct? How do you know? Now, let's look back at whenever I take a negative 15 and put it in parentheses and then do a 6th power. The reason I put the parentheses like this is because whenever you have an exponent, you want to be sure that you are understanding. You need to make sure that you know that this, and I should have explained that earlier, sorry, are not the same thing. And the reason is because this is how this reads. This one right here says negative 15 taken to the 6th power. So this tells me that I already have the number 15. Because remember, parentheses means you look at that first. So the parentheses say I already have negative 15. And that's being multiplied by itself 6 times. But if I look over here, there's nothing that tells me what to look at first. This is telling me, think about order of operations. This is telling me that I have the number 15 to the 6th power, and then I take the negative of it. You cannot do it in that order because you will not get the same answer. If you don't believe me, put it in your calculator. Negative 15 in parentheses to the 6th power will give you a different number than this negative 15 to the 6th power. Because you need to set it apart that 15 is by itself and being negative 15 is by itself and being multiplied by a total of 6 times. It is not 15 being multiplied by numbers by 6 times and then adding a negative or then taking the negative of it. Because remember, in order of operations, exponent would come first. So that means you would have to take 15s and multiply by itself 6 times and then take the negative of it. But if you put the parentheses around it first, this clarifies that I have negative 15 first, and that's being multiplied 6 times. So that is why Josie is not correct. You have to make sure whenever you have a negative number that you put parentheses around it. Okay, I want you guys to go ahead and start on the problem set, as well as do a Google Forms that I've created for you to finish out this lesson. I'll see you guys next time.